So let's finish off Unit 2 here, this last topic. And what we need to do is we need to come up with the derivatives of the trig functions that we have not covered yet. And that would be tangent, cotangent, as well as secant and cosecant functions. So let's review some things that we're going to need in order to derive these particular derivatives. The first thing that I need to look at is I need to go back and remember some of the derivatives that we learned back in topic 2.7. In topic 2.7, we showed using the limit definition of a derivative, that the derivative of sine of x was equal to the cosine of x. We also showed that the derivative of cosine of x was equal to negative sine of x. And so if we know those two derivatives and we can break these functions into sines and cosines, we can use this piece of information. The other thing that we're going to have to remember is from the previous topic, topic 2.9, we need to recall the quotient rule, which says that if I take the derivative of a quotient of two functions, and the notation we used f of x over g of x, that was equal to g of x times f prime of x minus f of x times g prime of x, all over g of x quantity squared. And so you can almost envision exactly how this is going to play out. For example, the first one we'll do is tangent. What I'm going to do is I'm going to break tangent, rather than doing the limit definition, which is very, very difficult for tangent. We'll break tangent, we'll just say that it's sine over cosine, because that's what tangent's equal to. And if we know that it's sine over cosine, we can apply the quotient rule. And you can see we may take the derivative of one of those pieces, and we already know them. So everything is going to just kind of plug into this quotient rule right here. One other trig identity called the Pythagorean identity is going to be used to help simplify, in particular, tangent and cotangent's derivative. You'll recall from pre-calculus learning that the sine squared of x plus the cosine squared of x is equal to 1. So we'll use this identity to kind of help rewrite the derivatives of tangent and cotangent into kind of the universally accepted derivative for those particular functions. So all of this little review, this from topic 2.7, this from topic 2.9, and this identity from pre-calculus are going to go into the derivations of the derivatives of tangent, cotangent, secant, and cosecant.